Hey everyone! So every single Grafana dashboard you look at is powered by PromQL queries. But let's be totally honest here, right? Most of us, especially support engineers, kind of treat these queries as this intimidating black box. You look at a panel, you see the squiggly lines, and you just pray you never have to actually touch the underlying code. But here's the thing. Understanding PromQL, it literally unlocks an entirely new level of troubleshooting.
Okay, let's dive into this because I promise you, PromQL really isn't arcane magic. It's essentially just a set of predictable, logical patterns stacked on top of each other. In this explainer, we're going to master just 5 core patterns, and once you've got these 5 under your belt, you're going to be fully empowered to troubleshoot practically any real-world incident that comes your way.
Quick look at our roadmap for today. We'll start with the PromQL black box, then look at why metric types matter, dive into rates and label filters, tackle the aggregation pattern, move on to percentile latency, and finally, wrap it all up with a real-world support scenario.
All right, Section 1, the PromQL black box. Let's start right from zero.
So imagine you're staring at a completely blank query editor in a demo environment, something like Grafana Play with the Prometheus data source selected. The absolute foundational step in PromQL is simply typing out a raw metric name. If you type HTTP requests total and hit enter, well, you're just asking Prometheus to hand over the most recent raw data points for that exact metric across your entire system. It's literally the base layer of data that we're going to systematically build upon. Moving on to Section 2, metric types matter. Counters versus gauges. Now, before we start manipulating that raw data, we absolutely have to understand what kind of metric we're actually querying. The two major ones you'll see are counters and gauges. Think of a counter as a cumulative value that only ever goes up or resets to 0, like total HTTP requests. A gauge, on the other hand, is a snapshot of an instantaneous state. It goes up and down arbitrarily, kind of like the active memory on your server. And knowing this difference, it's crucial because it dictates the actual math you're allowed to use. Which brings us to what I call the golden rule of PromQL. This is a true senior SRE axiom. Never, ever use the rate function on a gauge, period. See, the rate function calculates a per-second increase. If you apply that to a gauge that's naturally bouncing up and down, PromQL is going to interpret those drops as counter resets. That throws off your math entirely and gives you completely nonsensical data. Just don't do it. Okay, Section 3, rates and label filters. Let's find that rate of change. Assuming we're safely working with a counter, let's look at arguably the most frequently used pattern in all of observability, calculating how fast a counter is actually increasing. Let's construct this syntax step by step, building from the inside out. Step 1, we grab our raw metric, HTTP request total. Step 2, we append a time window in square brackets right at the end, like 5M, for 5 minutes, which turns it into a range factor. And step 3, we just wrap the whole thing in the rate function. So this query calculates the per-second average request rate over the last 5 minutes. Now what's really interesting here is how smart PromQL is under the hood. The rate function automatically detects and adjusts for counter resets. So if your app suddenly crashes and the counter drops back down to 0, rate function handles the math seamlessly. Your graph won't suddenly break. If you actually run this in Grafana, the visual output transforms from a constantly climbing, honestly pretty useless raw number into a highly readable, smooth line graph representing your actual requests per second. It even does this neat trick where it extrapolates the calculation to account for occasionally missed metric scrapes. It's super handy. But look, normally we don't really want to look at all the traffic, right? We usually want to isolate a very specific issue. And that is exactly where label filtering comes into play. Inside curly braces, we can add filters. So here, service equals payments isolates just our payment service. Then adding status code equals to 5 dot uses a little regular expression to match any 500 level server error. So now we're specifically tracking the per-second rate of air traffic just in the payments system.
Section 4, the aggregation pattern. Let's talk about grouping the noise.
So, filtered rates will often return dozens of lines on your screen, literally one for every single pod running your service. We need to aggregate that. But before I show you the exact query, I gotta give you a crucial warning. Always calculate the rate first, and then sum it up. Summing first destroys the individual time series data underneath, meaning PromQL can no longer detect those application restarts we talked about. Remember, rate first, then aggregate, every time. So, following that rule, the correct aggregation pattern looks like this. Sum, rate, HTTP requests total 5M, by service. We've taken our trusty rate query and wrapped it in a sum operator, and then we just added by service right at the end.
This tells Prometheus, hey, roll up all the individual pod or instance data and group the total output strictly by distinct services.
And this brilliantly illustrates how chaotic, noisy data becomes instantly organized. Instead of a mess of 50 overlapping, unreadable lines, your visual output is now a really clean graph, displaying distinct stacked lines. You can clearly see the total request rate separated perfectly, service by service. Moving on to Section 5, Mastering Percentile Latency. Let's measure that slow tail.
All right, now let's pivot to the boss level pattern. When you're dealing with SLAs, a simple average latency totally hides user pain. Think about it. If 90 requests take 10 milliseconds, but 10 requests take 5 entire seconds, the average might still look fine. But 10% of your users are absolutely miserable. Enter histogram quantile 0.95, comma. This calculates the 95th percentile, telling you exactly the latency experienced by the slowest 5% of your requests. Okay, so we have our metric types, our rates, our label filters, our sum aggregations, and now our quantiles. The really big question is, how do we combine all of these stacked patterns to prove a specific API is failing when the pressure is really on? Which brings us to Section 6, our real-world support scenario. Time to put all this to the test. Let's put our support engineer hats on for a second. It's a busy Tuesday. A major client is on the phone complaining, loudly, that the payments API is super sluggish. You quickly look at the timeline. There was a new code deployment exactly 3 hours ago. You need hard data to prove whether this is a real backend issue before you go and open a higher priority escalation.
So you jump into Grafana Explorer and build this fully stacked query. Now take a breath, don't panic, and let's just look at it from the inside out. We grab the duration bucket metric for the payment service. We take the rate over 10 minutes. Then we sum it, making sure to keep the Lee label, which, by the way, is mandatory to preserve the bucket structure of a classic histogram. And finally, we wrap the whole shebang in histogram quantile 0.95. So the crucial point here is that this massive, intimidating query, it's literally just the 5 basic patterns we just learned, nested together.
You hit enter, the graph loads, and the visual output confirms it. The P95 latency line was hovering right around 200 milliseconds earlier, but exactly 3 hours ago, right when that deployment dropped, it spiked strictly above 2.0 seconds, and it has stayed there ever since. Boom, you have your absolute proof. You screenshot the graph, attach it to the ticket, and confidently open that escalation.
See? PromQL is no longer a black box to you. You understand that metric types matter, you know how to calculate rates, filter labels, properly aggregate, and extract those tricky latency percentiles. Honestly, the absolute best way to cement all this is to get hands-on. So, are you ready to open up play.grafana.org right now, write a query, and maybe even intentionally break it just to see what happens? Get out there and explore your data.